Good day to everyone. We are Group 5 and our given topic is the landscape of memory, mental image, maps, and proposition. First is communicating knowledge, picture versus words. According to dual theory, we use both pictorial and verbal codes for representing information, Fabio 1969 to 1971, in our minds. These two codes organize information into knowledge that can be acted on, stored somehow, and later retrieved for subsequent use. So, si Alan Fabio daw is, siya yung nag-suggest um, na yung minds daw natin is may two types of codes, which is nagre-represent to ng information, which is pictorial codes and verbal codes. So, what is pictorial code? So, pictorial code, these codes resemble the object they represent, like mental image. For example, is may naisip kang puno, and yung naisip mong puno, papasok yun sa mental image mo, and magpo-form yun ng tree. Opposite naman sa verbal codes. When we say verbal codes, these codes are used words and language to represent information. For example is, yung mental imagery mo naman, yung mental imagery mo naman is yung nag-form ng tree. And then, maisip mo agad yung word na tree. O how it works. So, when we encounter information, our brains process it using both pictorial and verbal codes. So next is the image illustrates the concept of communicating knowledge through picture versus word, showing a cat under the table, and it provides two ways to describe a scene. So first is the cat is under the table. C, under cat table. So B, the cat is under the table. This is a sentence using words to describe the cat position. And C, under cat table. This uses a more abstract symbolic representation indicating the spatial relationship between the cat and the table. Ayan, sabi dyan, we may represent things and ideas and picture in words. Neither picture nor words capture all the characteristics of what they present, and each more readily captures some kinds of information than other kinds. Some cognitive psychologists have suggested that we have some mental representation and reassemble pictorial, analogous image, other mental representation that are highly symbolic, like words, and perhaps even more fundamental propositional representation that are in the pure abstract mentalists, that is neither verbal nor pictorial, which cognitive psychologists often represent in highly simplified shorthand. So, sabi dyan, cognitive psychology suggests that we have different types of mental representation. First, daw is our pictorial representation. Yung pictorial representation is like an image. This representation resemble what they represent that are good for spatial and visual information. And next is symbolic representation, like words. This representation are abstract and use symbols to convey meaning, making them good for verbal and linguistic information. Last is propositional representation. These are abstract fundamental representation that capture a meaning and a basic form independent of words or image. So these different types of representation allows us to process and understand different kinds of information in our environment. So ayan, picture in your mind mental imagery. So, sabi dito, imagery is mental representation of things that are not currently seen or sensed by the sense organs. In our minds, we often have image for object, events, and setting. For example, recall one of your first experience on a college campus. What what were some of sights, sounds, and smell you sensed at the time? Cut grass, tall buildings, or tree-lined paths. You do not actually smell the grass and see the buildings, but you still can image them. Mental imagery even can represent things that you have never experienced. So next, can your brain store image of your face? Yan. As you can see, the hourglass, sabi dyan, symbol can represent ideas in our minds. This hourglass illustrates that we can depict the passage of time in various ways. We cannot necessarily need number. So the image in a hourglass, a time measuring device comprising two glass bulbs rather, connected vertically by a narrow neck that allow a regulated flow of material, typically sun, from from upper from upper bulb to the lower one due to gravity. Hourglass are also known as sunglasses, sun timers, or sun clocks. The time companion the image states the symbol can represent ideas in our minds. This hourglass illustrates that we can depict the passage of time in various ways. We do not necessarily need the numbers. Ayan, so next is In the Lap of Stephen Gosling, Singing with the Mind's Eye. If asked to decide what shape Mickey Mouse ears are, most people report that they visualize the cartoon's figure ears and see that ears are circular. Visual mental imagery hints of such singing with mind's eyes, and is used not only to recall information, often that use has not thought about previously shot, such as the shape of the rodent eyes, but also in various form of reasoning. So, Stephen Coslin research on visual mental imagery showed that people use mental image to recall information, reason and first recall information, and second reason and problem solve. When asked about specific details like Mickey Mouse ears, people often report visualizing the image and seeing the mental answer, demonstrating the rule of mental image and recognition.
Good morning everyone, my name is Shalon Mabihar and now I am going to tell you about proposition. So what is a proposition? A proposition is the smallest unit of thought that can be true or false. It is a relationship between concepts like cat is under the table. Tignan nyo yung picture dito, yung example. The cat is under table and see under cat table. So if we compare, the cat is under the table and table is above the cat, magkaiba silang sentence. Pero same lang yung meaning. And that meaning is the proposition. Yung format niya is usually relationship, subject, object. Using propositions, instead of remembering full sentences or images, our brain breaks ideas down into simple codes like who did what something looks like, or where something is. So, ang sinasabi na using propositions, when we imagine or remember something, hindi yun actually nakasave sa head natin. Hindi yun siya nakasave as picture or word sa utak natin. Instead, nakasave siya as an abstract idea sa utak natin, not what we saw or what we heard. Hindi yung exact image or yung sentence na nakita natin. Hypothetical construction of propositions is so widely accepted among cognitive psychologists. Propositions can describe many things like, tignan nyo tong picture dito, nandito yung types of relationship, actions, attributes, spatial positions, class, or category membership. Propositions are expressed in a shorthand form known as predicate calculus. Kaya siya tinawag na predicate calculus para mas madali mapakita yung meaning ng mga idea. Pero hindi ibig sabihin na this is how our brain store ideas. Pinapakita lang kung ano yung posibleng nangyayari sa utak or nire-represent natin ng utak natin. Itong format na to nakakatulong siya sa mga psychologists mag-explain kung anong nangyayari sa mind natin. Pero model lang siya. So if babalikan natin yung table, dito sa first example na nasa table, the first sentence is a mouse bit a cat. Sa propositional representation niya, bite, action, mouse is the agent of action, and cat is the object. Nakikita rin na nandoon ang action. Sino ang gumawa ng action? Yung mouse. sino ang apektado, ang cat, and so on. Yung ini-store lang ng utak natin ay ang relationship ng action. Sa pangalawa naman ay ang important ay alam natin ang fur ay attribute ng mouse. Sa last column ay image representation. Pero sa preposition, idea lang yung nakastore. In short, preposition does not depend kung ano ang image ng bagay, but kung paano sila nagko-connect. Each time na gumagamit tayo ng prepositions, we understand agad ang essence ng idea, if it's action, attribute, location, or etc. Ganito mag-process ang brain natin para mas mabilis yung pag-process ng meaning, not just the visual memory, because in prepositions, we focus more on logic, meaning, and relationship between things. Do propositional theory and imagery hold up to their promises? Do we represent information in our memory by means of propositions or mental images? Scientists found that both systems are active, so our brains are flexible. We switch between images and propositions depending on the task. So, let's say for example, may nabasa kang isang sentence from a book yesterday. Hindi mo man maalala yung exact words, pero you will still remember kung tungkol saan yun. Ganon yung propositional theory. Some tasks are easier with mental images, others with propositions. That's why it came out na we both use mental imagery and propositions kasi nakadepende siya sa situation kung alin ang need natin between sa kanilang dalawa. Like these examples. If you're doing something visual like remembering directions, imagery helps more. But if you're solving logic problems or reading complex ideas, propositions work better. Limitations of propositional theory. Propositions are great for storing meaning and relationships, like who did what or what something belongs to. But not everything in our mind is logical or easy to explain with words. Example is this image. Tawag sa image na to is duck-rabbit illusion. Kung titignan nyo, some people see a duck looking to the left, others see a rabbit looking to the right. Kung ano man yung nakikita nyo, both siyang nakikita din ng ibang tao. What's important, you can mentally switch between the two interpretations. Ngayon na, kung titignan nyo yung picture, makikita nyo both duck and rabbit. Now, we can easily switch seeing it a duck or a rabbit, diba? Pero if we try to explain ang switching na to using prepositions, would be impossible. Kasi again, prepositions only store meaning and logic, not how something appears visually. Dito na hindi maa-apply yung prepositions. That's when the time na mas powerful ang mental imagery kasi yung task is more on visual, like imagine how a shape rotates, see a face in your head, or to mentally walk into a room. Yun yung purpose ng mental imagery. B. The bird silhouette shape. This image can be interpreted as a flying bird or simply a blue abstract shape. It shows how our brain can imagine different meanings from one image without changing the picture itself. Next, the snail-elephant illusion. This one can look like either a snail or a side view of an elephant's head, depending on how you look at it. Your brain forms different mental images from the same drawing, and this is why scientists say propositional theory is useful, pero hindi niya na-explain lahat kung paano tayo mag-isip. If involved ang pictures, mental imagery is still very important.
Good day everyone, I'm Antoinette Tanyosos and I will be discussing the mental manipulations of images. So first, let us talk about the functional equivalent hypothesis. It is a prominent theory in cognitive psychology that explores the relationship between visual imagery and visual perception. While visual imagery and visual perception are not identical processes, since one involves mental representation and other involves actual sensory input, they are believed to be functionally equivalent. So, in short, the process of how we see things is not similar to how we imagine things. And functionally equivalent processes are strongly analogous, meaning they share similarities in structures and use. For example, when people visualize objects, manipulate images in their minds, or solve spatial problems using mental pictures, they're using their visual imagery in ways that mirror how they would interact with real world visual stimuli. So this hypothesis suggests that mental images behave like real perceived image that can be scanned, rotated, or examined for details, just one would do with an object in front of them. Next is the neuroscience and functional equivalence. It is all about how our brains process information when we see or imagine things. It mentions a study where people were asked to either look at a picture or imagine it in their minds. So the study found that similar parts of the brain were active when they did both activities, so especially in the front and the back of our brain. However, the areas of the brain responsible for actually seeing things did not overlap. Also, it discusses the schizophrenia, a mental illness where some people hear things that aren't really there, called auditory hallucination. These hallucinations are caused by the brain creating sounds internally rather than from external sources. So, people with schizophrenia have trouble telling the difference between sounds they hear in their minds and sounds from the outside world. Studies have shown that the parts of the brain responsible for hearing and language are overly active during these hallucinations, suggesting a problem with how the brain processes information. So there's a connection between what we see or hear in the outside world and what we imagine in our minds. This can help us better understand how our brains work and how mental illness like schizophrenia affect our perceptions of reality. Um, there is a psychological evidence supporting mental retardation, particularly from studies involving primates and human brains, imaging in monkeys. Cortical activity is the motor cortex indicated anticipation of movement, even without physically action, suggesting mental retardation capabilities. Human studies using brain imaging such as fMRI shows that the same brain areas involved the perception, especially those linked to hand movement, are also active during mental retardation tasks. So next is the mental retardation. Mental retardation is when you mentally imagine an object and rotate it in your mind, just like how you can physically rotate a water bottle in your hands. So in a study, participants were shown pairs of pictures of 3D shapes that were rotated either in a 2D plane or in 3D shape. They were also shown other shapes that were not rotations of the original one. The participants had to decide if a given image was a rotation of the original shape or not. So the time it took for participants to answer this question depended on how much the shape were rotated. The more the shapes were rotated, the longer it took to respond. Interestingly, whether the shapes were rotated in 2D plane or in 3D space didn't make much of a difference in response time. So response time for mental rotation by response time for mental rotation, Kyle's research suggests that mental rotation becomes increasingly automatic with age and practice. Children and young adults show faster response time with practices, and their performance is not hindered by simultaneously memory tasks, indicating memory rotation may operate automatically. This growing automation across childhood and adolescence likely reflects improved visuospatial skills, as faster mental rotation is linked to greater spatial memory accuracy. Next is the intelligence and mental rotation. It is all about how our ability to mental rotate object is connected to our intelligence. So researchers like Shepard have studies this mental retention ability and found that there is similar to the spatial problems we see in intelligence tests. So, for example, on a test like a primary mental ability test, you might be asked to mentally rotate a picture of an object in your mind. So the ability to mentally rotate object is a key part of understanding intelligence. So by studying how our brains create mental images and process information, researchers are able to learn more about how we adapt and problem solve in different situations. This research help us understand how our mind work and how we use our intelligence in everyday life. So lastly, the gender and mental retardation. Research on mental retardation has shown mixed findings regarding gender differences. Some studies report a male advantage while others do not, especially when using the character-based stimuli, which may engage a different cognitive processes. Notably, no gender differences are found in young children or in their brain activity during this task. So neurological studies revealed that men and women may use different strategies. Men show greater parietal lobe activation, typically on the right side, while women shown more bilateral activation, including the inferior frontal areas. So women also have more gray matter in the parietal lobe, which may contribute to greater effort needed and a performance at disadvantages in mental rotation tasks. So importantly, training has been shown to reduce or eliminate these gender differences, suggesting they are not fixed but modifiable.
Good day everyone, I am Sandra Kailamzon and I will report the topic of synthesizing images and propositions.
Do experimenters' expectations influence outcomes? Research on mental imagery explores whether visual imagination operates similarly to actual perception, functional equivalence hypothesis, or relies on abstract symbolic representations, propositional hypothesis. Key findings demonstrate that mental scanning follows linear time-distance patterns, mirroring physical perception. Jolicoeur and Coslin, 1985. However, studies also reveal that experimenter expectations can unconsciously influence participants' performance, even in computerized tasks. Intons, Peterson, 1983. Neuroimaging shows overlapping brain activation for imagery and perception, though spatial and visual imagery may involve distinct processes. While functional equivalence has strong empirical support, alternative propositional interpretations persist, reflecting deeper philosophical divides between empiricism and rationalism. The debate remains unresolved, highlighting the need for rigorous methodologies to minimize bias and clarify the nature of mental representations. Mental models represent a third form of knowledge representation alongside propositions and visual imagery. Johnson Laird, 1983. Unlike purely abstract propositions or sensory-based images, mental models are dynamic structures that individuals construct to interpret experiences, often based on implicit theories rather than objective reality.
Johnson Laird's mental models. The first one is formation and use. It determinate descriptions, precise spatial information, lead people to form mental models, enabling inferences beyond given details but producing verbatim recall. Manny and Johnson Laird, 1982. It also indeterminate, ambiguous descriptions discourage mental model information, resulting in better verbatim recall but fewer inferences.
The second mental model is the multimodal imagery. It consists of two imagery, which is the haptic and auditory. Haptic or touch-based imagery in blind individuals shows functional similarities to visual imagery, activating overlapping brain areas. James et al. 2002. Blind participants exhibit spatial processing patterns like distant time relationships to sighted individuals. Kerr, 1983. Auditory imagery mirrors perceptual processes, with pitch, shifts, and familiar songs activating auditory cortex regions. Kramer et al. 2005. The third mental model is the faulty models and learning. Inaccurate mental models like misconceptions about heat or respiration persist without correction. Hands-on experiences, especially when paired with explicit predictions, help revise these models. Model et al. 2000. The purpose of Johnson-Laird's mental models is its bridge abstract reasoning and sensory-based representations, explaining phenomena like non-visual imagery, which is the haptic and auditory. They also highlight the role of experience in shaping and correcting cognitive frameworks. The theory complements, rather than replaces, propositional and imagery-based accounts, offering a unified framework for diverse cognitive processes.
So let's proceed to neuroscience, evidence for multiple codes. Participants involved in a research project involving cognitive tasks can be influenced by expectations of the researcher. So ganito yan. If a research study about cognitive tasks, like for example, mga activities na involve yung thinking ng isang tao, like memory test, attention tasks, decision making, or problem solving. Possible na ma-affect yung performance ng participants because they are aware na may nag-o-observe sa kanila. Alam nilang may researcher na naghihintay ng certain results or behavior, so minsan unconsciously nag-a-adjust sila sa expectations ng researcher. Ito yung tinatawag na experimenter bias o demand characteristics, where participants try to behave the way they think they're supposed to. But it seems implausible that such factors would equally influence the results of neuropsychological research. So, ibig sabihin, hindi ganon kadaling ma-apply yung ganitong bias sa neuropsychological studies. Why? Kasi usually, may mga participants na may brain damage o neurological impairments. And because of that, they do not know kung ano yung specific na behavior o functions na ina-expect ng researcher from them. They can control the outcome ng tasks in the same way na kaya ng typical or normal participants. Likewise, brain damage patients do not know that particular lesions are supposed to lead to particular kind of deficits. Katulad ng mga sinabi ko kanina, hindi rin alam ng mga patients na may brain damage kung ano talaga yung effect ng specific na injury sa brain nila. It means kung may lesion sila or yung damaged area sa brain, hindi nila alam na yung part na nasira ay connected pala sa cognitive or perceptual abilities nila. Indeed, the patients rarely know where a lesion is after deficits are discovered. So dito, sinasabi na karaniwan hindi alam ng mga patient kung saan sa brain nila yung may damage. Malalaman lang nila kapag nagsimula na silang makaranas ng mga problems like hirap magsalita, maglakad, magbasa, or makaalala ng mga informations. Next is left brain or right brain, where is information manipulated. So, traditionally, sabi ng neuroscience, hati raw ang trabaho ng brain natin. Right hemisphere daw yung bahala sa visual spatial tasks like imagining shapes, understanding directions, o yung kapag iniisip mo kung paano iikot yung isang object. Left hemisphere naman is more on verbal and symbolic tasks like understanding grammar, solving math problems, or explaining ideas through words. Kaya nga 'di ba pag sinabing left brain ka, parang logical or analytical ka daw. And right brain ka if you're artistic or visual. This was supported by studies on split brain patients. Pinakita talaga na iba-iba yung processing ng bawat hemisphere.
Pero ngayon, based on new research, both hemispheres actually work together more than we thought. Let's say na nagbabasa ka ng instructions kung paano bubuuin yung isang bookshelf. Yung left brain mo, nagpa-process ng words. Attach shelf A to panel B. Pero habang binabasa mo yon, right brain mo naman is visualizing how it will look or fit together. So kahit verbal task siya, may visual spatial component din, meaning both sides ng brain mo ay gumagana. Some researchers even think na yung dominance ng right brain sa visual task might just be because the left brain is too focused on language. Kaya parang less involved siya sa ibang task. Sa ngayon, imbes na isipin natin na left versus right, mas accurate na sabihin na teamwork yan. Pareho silang may ambag depende sa ginagawa nating tasks. Okay, so moving forward to two kinds of images, visual versus spatial. While examining visual imagery, researchers have found that images actually may be stored or represented in different formats in the mind, depending on what kind of image is involved. Here, visual imagery refers to the use of images that represent visual characteristics such as colors and shapes. Visual imagery is when you imagine how something looks, like its color, shape, or texture. For example, inisip mo kung ano yung itsura ng isang apple. Pula ba siya, malaki or maliit? Spatial imagery refers to images that represent spatial features such as depth, dimensions, distances, and orientations. On the other hand, spatial imagery is about how things are arranged in space, like size, distance, and position. Parang iniisip mo kung nasa kaliwa ba or nasa kanan yung bagay or kung paano mo siya i-rotate. They studied a man named LH who had a brain injury at 18 years old. That injury damaged parts of his right and left brain, specifically the temporal and occipital lobes. Dahil sa damage, LH had difficulty with both visual and spatial imagery, but not equally. This shows the areas of LH brain that were damaged. The blue areas highlights the damage in the right temporal lobe, left temporo-occipital region, and the right frontal lobe. These areas help us recognize objects and visualize things. So damage here explains why he had trouble with visual imagery. So in this illustration, Panel A and Panel B drawing tasks. Panel A shows the original objects given to LH. Panel B shows how he copied them. So for the observation, he could draw the objects accurately, but he couldn't recognize or name them. So his motor skills and memory for shape were fine. Pero hirap siya sa meaning and identification, and this is visual imagery problem. Panel C for visual tasks bar graph. This bar graph shows how well LH did on tasks like identifying animal tails, colors, sizes, and shapes. The light blue bars, or for normal people, are higher than the dark blue bars, or for LH, meaning he struggled with visual recognition and detail. For Panel D, spatial task bar graph, this shows tasks like mental rotation, letter positioning, and movement in space. Here, LH's performance is almost normal. Ibig sabihin, kahit na may damage, his brain still handled spatial tasks well. So, in summary, LH's case shows na kahit may brain injury siya, his brain was still able to do spatial tasks like imagining movements or positions. But he had a hard time with visual tasks, like identifying or describing objects. This suggests that visual and spatial imagery are handled by different parts of the brain.
Well, let us now proceed with the spatial cognition and cognitive maps. So, most of the research I've looked at so far, based on Sinan ni Prof. Janine, it focuses on how we create mental pictures based on what we see. So, some example of this is like imagining something after looking at it. But other research naman shows that we can also build mental maps by just moving around or through and interacting with our surroundings. When we say naman daw that cognitive maps, these mental maps naman can help us to track of having mini version of the real world in our heads. So in this next part of my report, we will be now talking about the spatial cognition and cognitive maps of rats, bees, pigeons, and humans. So in one study, the researchers were interested in the ability of rats to learn a maze. So nakikita po natin here sa figure 7.14 wherein Tolman and Honzik 1930, the rats were divided into three groups. So first, the group 1 of the rats kept food at the end of the maze. So makikita natin meron tayong starting point here and we have the end of the maze. So these rats quickly learned the right path and made fewer mistakes over time. So by doing that, kung paano nagkaroon sila ng kung paano nila napag-aralan na mas mabilis, nagkaroon ng rewards yung mga rats. After the rats, we will now proceed with the bees. So, ang sinasabi naman dito that bees are pretty smart for tiny creatures. Why? Because they can remember where food is and picture how to get there in their minds. So, ang even cooler nga raw po sa mga bees, they can communicate, this info to other bees using dances. So, ito pong sinasabi dito na patterns of dances ay nakakatulong daw to communicate with the other bees. So, next, we have the pigeons. So, let's proceed with the spatial cognition and cognitive maps of pigeons. Human pigeons are noted for their excellent cognitive maps. These birds are known for their ability to return to their home from distant locations. This quality made the birds useful for communication in ancient times and even in the 19th and 20th centuries. Extensive research have been completed on how pigeons form these maps. So, yung pigeons daw are really good at finding their way back to their home even kahit gaano kalayo sila. So, that's why nga raw the people use them to carry messages sa mga past like mga story before even in the 80s and 90s. So the scientists have studied how pigeons are able to do this. So kung paano nga ba ginagawa ng mga pigeons yun ay pinag-aralan ng mga scientists. So it turns out that a part of their brain called we call the hippocampus is super important. Especially daw that the left side of it. So bakit nga ba? It's because if the left hippocampus is damaged, pigeons have hard time finding their way back home. So even if any part of the hippocampus is damaged, their navigations gets worse. Let us proceed with the spatial cognition and cognitive maps of humans naman. So humans seem to use three types of knowledge when forming and using cognitive maps. So when people make mental maps now, that is called cognitive maps, they use to understand where things are using three kinds of knowledge. First, we have the landmark knowledge. It is information about particular features at a location and which may be based on both imaginal and propositional representation. So, the landmark knowledge daw, this is about remembering specific things at a certain places. So, it is like a big tree or a statue. This can be remembered as picture in your mind or as facts you know. Next, we have the route road knowledge. So, sa route road knowledge daw, it involves specific pathways for moving from one location to another. So, it may be based on both procedural knowledge and declarative knowledge. So, when we say route road knowledge, this is knowing the paths to get from one place to another. So, it is example of this is like how to walk from your house to school. So, it involves knowing the steps, how to do it, and also the facts. So, like where to turn, etc. Next, we have the survey knowledge. So in survey knowledge, it involves estimated distances between landmarks, much as they might appear on survey maps, and it may be represented imaginally and or propositionally. So dito naman sa survey knowledge, this is like having a map in your mind or head. So where you know the distance between different landmarks and how they are arranged in space. So you might picture it or know the measurement. So in short, when we picture maps in our minds, we are both using images and facts like distances or directions in words or numbers. When we use landmark like route road and survey knowledge, we sometimes use rules of thumb that influences our estimations of distance. These rules of thumb are cognitive strategies termed heuristics. So, etong tinatawag nating the rules of thumb is strategies term na tinatawag na heuristics. So, most basically, a rule of thumb is a simple guideline or shortcut used to make quick decisions or guesses. So, it is not always perfect or exact, but it usually works well enough in our everyday situations. For example, nito, in regard to landmark knowledge, the density of the landmark sometimes appear to affect our mental image of an area. So, sinasabi lang dyan that if there are more landmarks, the distance feels longer. That's the rule of thumb that our minds or brain uses to estimate distances. So the use of heuristic is manipulating cognitive maps suggests that propositional knowledge affects imaginal knowledge. So, ang sinasabi lang dito that when people think about places or maps in their minds, such as the tinatawag natin cognitive maps, they don't always picture them exactly as they are in real life. So, instead, their conceptual knowledge on what they know or believe about the world can change, distort their mental images. So, itong idea na to is supported by the research that shows people often use shortcuts in thinking. So, ayun ang tinatawag naman natin na heuristics, which can lead to systematic mistakes. So, we have here the three types of the most common mental directions people make. First, we have here the right angle bias. It says that the right angle bias is what people assume, such as street intersection or on 90 degrees. When we say that, people assume street intersection are 90 degrees even if they weren't. So, ayun po yung sinasabi na right angle bias. Well, the symmetry heuristic, kapag sinabi naman natin symmetry heuristic naman, this is how people think shapes like states or countries daw are more symmetrical than they really are. Next is we have the rotation heuristic. So, when we say naman your rotation heuristic naman daw, ito yung sinasabi na kapag ang isang bagay is slanted, halimbawa sa maps or borders, they remembered as being more straight either than vertical or horizontal. Next, we have the alignment heuristic. Kapag sinabi naman nating alignment heuristic, if things aren't perfectly lined up, people tend to mentally adjust them so they are aligned. Lastly is we have here the relative position heuristic. Kapag sinabi naman natin relative position heuristic ay it is about people remember the location of places based more on general knowledge. So, we have the creating maps from what you hear. So, ito yung text maps. So, when we make mental maps, we can actually make mental maps not just by seeing places or following directions, but also by hearing or reading about them. So, even if someone only gives you a verbal description of a location or route, you can still create the pretty accurate mental images of the place. So, gaya na sinabi doon ni Tversky, Sa research niya, it look at how people imagine these places when they read about them. So, she found out that people tend to imagine themselves inside the scene.